So I'll be talking about something quite interesting today. I'm sure you guys have seen the topic already, and it's something that I spent some time doing some research on. It's not a regular topic you will see out there. If you go to regular AWS stuff, what you hear, they're talking about a particular service, they're talking about how to use a service to do something. But hey, from my experience of doing this for the past 6 years, I noticed that there is this gap that is not usually filled up, which is having to solve more real life product oriented problems that people have. Okay, so this is first in the series of presentations and blog posts and books I'll be doing around that kind of concept. I noticed that when people talk about cloud, they are more concerned about the services than what the services can do. You know, when people talk about maybe an EC2 instance, they're talking about EC2, T2X/, they're talking about, okay, how do I use it for a product? What does it do when I want to scale up? Those are the real life scenarios on what these things are. Lastly, before I start, I have a prodigy here that I was introducing to a new project, and when I explained to him what needs to be done for the client, and he was confused. He's like, I've been doing AWS for the past 1 year. I've been doing all the courses, but all these things you are saying, they are so new to me. But I'm like, I'm talking about EC2. I'm talking about EBS. Why does it look like you are getting confused, you know? So that's the reality of a lot of people that do this stuff. They are more consumed by the service names, what the service is, than the value or what it means in real life in terms of solving real business problems, real product problems, and real human problems, you know, so solving problems in real life. Okay, without further ado, I'll go straight to the topic of the day. I'm going to share my screen. I just want to confirm. I want you to confirm that you can see my screen when I do. Okay. Can you see my screen?
Yeah, you can see.
Yeah.
All right. So we're talking about nine strategies to improve on your user experience on your AWS cloud deployment. So the main topic here is user experience in cloud products. You hardly hear people talking about user experience in the cloud. What you hear most times is compute, you hear about mobile, you hear about AI and machine learning. But the funny thing is that across each of these services and products, there is always a user experience that is attached to every single thing. And it's not usually taken into consideration. It's taken as a back burner. Okay, but here in this slide, I'm going to show us how we can, you know, be more considerate about how the users see our product, how they feel our product. Because the truth about any product or any application or any website is that it is how the user perceives the product that will determine how the user will interact with the product, how the user will trust the product, how the customer can become a returning customer, and every other thing that goes with that product. It's all about the experience the user gets. All right, so this is a brief of my profile. Emmanuel has already said a couple of things already. I started software engineering a couple of years ago. I started using QBasic in Windows 98, and I have experience working with languages such as Node.js, Python, C#, and C++.NET. I used to work in Synfix. Sorry, I don't work in Synfix anymore. That was my role before. When I'm not in AWS, I love watching movies. My favorite movie is The Flash, superhero movie. And I'm a father of two lovely girls. I have 2 daughters. Okay, let's look at what we'll be talking about today. The first thing we'll talk about is degraded performance. The next thing we'll talk about is DNS and static site failover. Next thing we'll talk about is DNS latency. We'll talk about CDN and caching. We'll talk about load balancing, application caching, appealing status page, mean time to recover, and hiding of exception and errors. So the first thing I want to talk about here is what we call degraded performance. Now, what is degraded performance? Now, this is a state when all the features of your application all the features of your application is not available for the user, but certain features are still available for the users. Now, microservices for the backend makes this possible, and using S3 can be very helpful. Now, what do we mean by degraded performance? So, for example, there are certain websites that you notice that you get to the website, you are able to shop in the website. Okay, let's assume it's an e-commerce website. You're able to add to cart, but for some reason you are never able to check out. Whenever you click on checkout, it tells you error in the system. Okay, it tells you there's an error in the system. Your checkout seems to never work. That's an example of what we call degraded performance. There are some systems where some new users are trying to sign up for the application. They can't sign up, but for some reason, those who have account before, they can log in. Do you understand? That's what we call degraded performance. There are also scenarios where some people are able to send emails, some other people cannot send emails. That's what we call degraded performance. Now, the advantage of degraded performance is that the system is not totally down. Okay, the system is not 100% down. Some parts of it are working, some parts are not working. Now, with that experience, a lot of customers are not going to totally leave your product or your application. Why? Because you are still serving some customers. Some people can still use the application. They can still get value for the system. There are sometimes you notice, and even in WhatsApp, it happens a lot of times. You can maybe make calls in WhatsApp, or you can send messages. Okay, or you can send messages, but your calls are not going. Okay, now because of that, what do? You resort to just sending messages instead of making calls. Now that is a better experience for the user than WhatsApp totally not working at all. When you launch the WhatsApp app, you can't even use it at all. You can't do anything. There is a very high chance that you will never come back to WhatsApp, or you never come back to that system, because there was a total downtime on the system. So a better design to give the user a good experience is to set up your system in a way that you can afford what we call degraded performance. The performance is not like a total zero, but it is not 100% functional. I don't know if I'm getting what you guys are getting what I'm trying to say. So in that scenario, some parts of the system are working, some parts of the system are not working. I've given some scenarios already where some applications, there are sometimes that you notice that some people can log in, some people cannot sign up. Some systems you add to cart, you check out, but you can't pay. Do you understand? So it happens a lot of times, and that is what degraded performance is trying to present to the user as the experience. So the user is not totally leaving the system, but the user is not getting total value for the system because there is a downtime. So that downtime does not affect the full system because of an architecture we call microservices architecture. So what microservices does is that instead of building everything as a single system, you break it into separate components, and each component is doing different things. Okay. Now, because they are broken down into separate components, when there's a problem with the system, with the full application, it doesn't affect all the components. It will affect some components, it will not affect some components. With that, you give your user what we call a degraded performance. It means that you can tell the user that we are working on it, we are sorry, this is what is working at the moment. When this part comes up, we will give you a feedback. Now, to cap this all, this is the reason why AWS has what we call availability zones. Availability zones are supposed to help you with what we call high availability, so that if one availability zone goes down, you can still use another availability zone. You are not going to have the same performance or the same availability, but you are going to have what we call degraded performance, but you can still use the system the way it is working. Okay, so I mentioned here that microservices for the backend makes this possible, and using S3 can be very helpful here. Now, S3 has very high availability, making your front end always available. What do I mean by this? If you are designing your application, it is always good. I always advise people that your front end, what I mean by front end is maybe the front end built in JavaScript, CSS, and HTML, should stay in S3. The reason for that is because of the high availability that comes into S3 by default, that you don't have to manage, you don't have to monitor, you don't have to scale. S3 does that by default. So if you have an S3, if you have your application in S3 front end, and you have the other part of the application as a microservice backend, you are always assured that your front end will always be available while you handle the systems that have problems in the back end and still deliver degraded performance to your customers, so that they don't go to your website and see a total shutdown of your system. Now, a use case here is with microservices, your whole system does not go down. I already mentioned that. And some services can serve customers while you work to get the services back. Now, some of the tools that can help you with microservices are Amazon EKS, which is for Kubernetes. We have Amazon ECS, which is also for container orchestration. And then you have Lambda and API Gateway, which is the serverless service from AWS. So Lambda applications are serverless applications that give you high availability. And you can also set up applications to be in a microservice design when you use AWS Lambda and API Gateway. The next technique is what we call DNS and static site failover. Now for this, what you have is a very different scenario. So having a static failover option for your website hosted in S3 can help give your users a good experience. Even when the main dynamic site is down, Route 53 can detect failed endpoints and route to the next available endpoint, giving your users the same experience without the knowledge of downtime or service unavailability. Let me give a very practical example of what I did one time. So in the company I used to work, there's a company called Terragon here in Nigeria that I used to work with. That was actually my early days in my career as a cloud engineer. And we were using a very simple website before, but the business wasn't happy with the website. So we needed to migrate into WordPress. That was like my first time of doing WordPress at that scale. I mean, company website with thousands of users coming into the website. The first few days was terrible for me. I mean, the downtime was just beautiful. We're having consistent downtime, okay? For whatever reason, I wasn't sure. So, I mean, I tried everything, I restarted the server a lot of times. I cleared up memory. It was still going down for some reason. I wasn't sure, which the problem was resource issue, okay? But I couldn't identify that. So what I did was I made what we call a static part of the website. There's a service called Jekyll, okay? Jekyll. You can use it to generate a static part of a WordPress website, of any website. What do I mean by static? What I mean by static is that there's no PHP, there's no database. It's just the same website, but no server side to it, just a client side to it, okay? So what I did in that scenario is when I had the static website, I took it over and dropped it in S3. And then I went to Route 53. Route 53 has a feature called what we call a routing policy called failover policy. What this policy does is that if you have two websites, okay, you can configure two applications in the Route 53 configuration and say, okay, do a health check continuously on the first one. If anything fails on the first one, direct all traffic to the second one. And that was exactly what I did. Now, what happened with that for me was that whenever there was a downtime in the main websites, people didn't know. I was the only one who knew. Why? Because whenever they still type the URL of the website still works. But it now had a degraded performance. Going back to the first point I mentioned, it means that they cannot maybe fill forms and submit forms. Okay, but the good thing about the website was that the only form we had was a contact page form, which people rarely used. So I was pretty much fine because people wanted to just come to the website, see what the company does, understand those who are in the business, the board of directors, see our case studies, see what we've done, and they leave. So my failover design practically solved my problem while I continued to find out what I needed to do to make sure that the main website was working optimally. Okay, so this failover concept can be used for a lot of other purposes. But I mean, the whole idea that the people who were using the website did not even know something was wrong give them the beautiful experience of still using that website as if everything was still fine, without even noticing a downtime, without noticing a failure. Because what Route 53 failover does is, once it does a health check and the main application is down, it will automatically route all traffic to the secondary configuration you have and start feeding the other one with traffic. So making a static alternative of your website and having it available on S3 to serve static content when the application is down. So this is a way you can sleep at night. You don't have to worry if there's a downtime. You can make sure you have a notification, but you are not worried that it's totally down. There's a lot of firefighting. You're going to fix it. You're going to make it come back up. You don't have to worry about all those things anymore because the failover, or what we call in real technical terms, disaster recovery site, is already serving traffic to the customers. The two major services that makes this very possible is Amazon Route 53 and Amazon S3, which I already mentioned down there. So Route 53 will help you with the failover policy, and S3, being that it's highly available and highly redundant, can serve your website and continue to serve it until you fix the initial website problem. Now, the next we have here is latency, DNS latency. How can we use DNS latency to improve the user experience of our application or our website? Now, the speed of your website is quite important to your customer. I mean, it's usually the reason people come back or leave your website. Okay, if it's too slow, they most likely will go for an alternative that's faster. Now, it takes milliseconds of delay to lose customers. Having latency very low is very key, and using servers closer to your customers is a way to have low latency. This way, your users get a better experience. Okay, now, we cannot overemphasize how we get so annoyed when a website is very slow. I mean, if you type a website and it's about 30 seconds to come up, most likely, if that was not very important, you're not going to go back to it. You're just going to ignore it. And next time you think of the website alone, you're like, this thing is very slow. So that alone is a lot of user experience for the customer. If the customer doesn't have a good experience in terms of the speed of your website, and they are not, whenever they go there, they have to wait for 30 minutes. When they click something, they wait for another 30 seconds. They click something, they wait for another 1 minute. They're going to say, is there another website that can do the same thing so that I can just get things done? Okay. So what is the use case here? The use case here is route requests to a region closer by profiling your load balancer, your IP address on Route 53 will improve the speed of your application. So there is also a latency configuration within your routing policy again on Route 53 that would help to identify the faster place to route your application to. So this will help to improve the speed of your website from time to time. So you don't have to worry about it. Now, let me expand this a little bit, why this is very important. If your website is just serving people in Accra, people in Kumasi, you are fine. But if you are serving people in South Africa, you are serving customers in Guangzhou, China, you are serving customers in Seoul, Korea, I mean, you're already traveling almost across the world. It means that if you decide to set up a server in Ireland, which is a bit closer to Ghana, you're not going to get the same experience for somebody in Seoul in South Korea. It's going to be slower because there is a Japan region that is closer to that person. So that's where the latency routing is very important. So when you configure latency routing, you can configure more than one what we call record sets in your DNS layer, so that you have the same application hosted in two different servers. But because you configure DNS latency with two different URLs based on the region, the Route 53 will get there and say, okay, you are visiting this website from South Korea. This data center or this application is hosted in Ireland. Ireland is too far, but there is a Japan region. I think I will route your request to Japan instead of routing it to Ireland. So in that way, the customer gets a faster experience in the application instead of because you hosted in Ireland, you have to route all traffic to Ireland. Your customers in New Zealand will get a very slow experience. Your customers in Australia will get a very slow experience because these places are very far from Ireland, unlike Ghana, where the customers are closer to Ireland. So this is where DNS latency is very important in giving your customers better experience because it is faster, because it's able to check which data center or which deployment is closer to your region. The next we have here is CDN and caching. Now, POP is actually an acronym for point of presence. POPs globally help to store CSS, HTML, and JavaScript closer to users. Now, the difference is clear when there's a CDN closer to a user in Japan visiting your website than the same user visiting your website on a server in Ghana. Okay? As if I know I was going to be talking to Ghana very soon. I think I was thinking about Ghana when I was preparing this. Okay, so I mean, it's very similar to the latency I already spoke about. CDNs, we call them content delivery network. That's the meaning of CDN. CDNs are all over the world, and they have practically changed the way we use applications. I'm going to give one very simple example that I always use when I'm talking about CDNs. Take a look at Netflix. Netflix launched globally, okay? But hey, the movies you stream on Netflix, they are not all coming from the United States. Netflix is headquartered in the United States, but hey, newsflash, your movies you watch on Netflix are not in the United States. What Netflix has done is that they have what we call point of presence. Point of presence are more or less what we call mini data centers. The new acronym for them are what we call edge locations, okay? What they are, I call them semi-data centers. Why I call them that is that they are not as big as a proper data center on availability zone, but they have data centers, okay? It might be half of an availability zone. And within those data centers, their job is to cache and store information. Now, if I need to watch a movie in Netflix in Nigeria here, funny enough, they have a data center just close to me here in Lagos. When I want to watch that movie, when I get into Netflix application, I can browse movies. Okay, that's the main application. And most likely it is on the Netflix network in AWS because Netflix is AWS. But maybe I play that movie. For that movie to be streamed over to me, it is coming from a data center right here in Nigeria, in Lagos, Nigeria, because it's going to take a longer time to transmit that data all the way from the United States over to Nigeria. It's going to also cost a lot of data to transfer it all the way from the United States over to Nigeria. So there's latency, there's also data cost, transfer cost. So instead of that, they decided to bring the movies over to Nigeria here. So that when I'm streaming it over in Nigeria here. It's going to be faster, and also I'm going to also have cheaper costs. They're going to be paying less in terms of data transfer cost of transferring that data over to me to stream that movie. This is the basic idea behind CDN and what we call edge locations. And this concept is being spread across different other examples, okay? So the whole idea of this is bringing servers closer to you. So the main application is actually in the United States. But what CDN or content delivery networks do is that because you have servers all over the world closer to people, they kind of copy some of the data, keep it in themselves, and redistribute it to you. So if you type facebook.com in Ghana, Facebook United States, Facebook is in the United States in California. Unfortunately, that is not where your request is going to. It's going to Ireland. Why? Facebook has another data center in Ireland for serving people in Africa. Because it's, like I said, it costs more money to transfer data all the way from Accra to San Francisco and back. And also the website is going to be slow. So instead of that, they have another data center in Ireland. So that when you say facebook.com, Facebook has what we call hydrated some data all the way from the United States into Ireland. And then when you are viewing your website, you are viewing pictures on Facebook, they are delivering it from Ireland. They are not delivering from the United States. So in that way, the application becomes faster, it becomes more efficient, and also they spend less in terms of data cost. That's the power of content delivery networks, and they are growing very fast. And it would be good to also know that AWS has POPs in South Africa, and they also have in Kenya. They are almost completing the ones in Kenya very soon. So there's a high chance that we'll be getting better performance in terms of applications that we use and content delivery networks for, most especially CloudFront in AWS. Okay. Now use AWS CloudFront to cache static or dynamic content to improve response time of your application. Now the two tools here, I mentioned a third-party tool here. I mentioned Cloudflare, but the AWS tool for this is called Amazon CloudFront. It's a tool that helps you in terms of caching and serves as a content delivery network. The next we have here is load balancing. So during periods of high traffic, you do not want users to experience a downtime because you are scaling up or down your system. I mean, it is before that you see websites put a banner and say, we are going down for maintenance. Please, who has ever seen that in Facebook? I have not. I mean, in the last maybe 10 years, okay? You see Microsoft say, oh, we are sorry, we are going down for maintenance. You hardly see that. Or Amazon is telling you, please, we're buying more data, we're buying more server, please give us some time. You don't get all this kind of information. Part of the reason for that is because they're using something like a load balancer. With a load balancer, you don't need to tell the customer that you are trying to add more resources or you're trying to remove resources because of traffic, and then you go shut down. You don't do that. Load balance can help you spread traffic during times like this. So because the load balancer helps to spread traffic across different servers, you don't have to worry about a downtime, because whenever any server is disconnected from the load balancer finds out and stops sending traffic to that particular server. It starts sending it to the ones that are available to it. Now, ensuring there is degraded performance and no downtime during auto-scaling activity. I mean, the worst you can get in load balancing is because maybe the website is a bit slower. Before you know it will pick up again. Now, because of what we call auto scaling, that is why that kind of thing can happen. So an example could be, let's assume you have 3 servers, okay, or you have 1 server and customers are, for some reason, the marketing team did a very beautiful marketing campaign and it's Black Friday, okay, and you have configured auto scaling and load balancing for your system. What's going to happen is that if for any reason your traffic is getting so high and the load balancer sees that, oh, it's like there is an increase, oh, this is the threshold set for me, it's going to create another EC2 instance and attach it to the load balancer. Now, between the time it receives that signal to create a new instance and it creates the instance, there is a high chance that the customer will experience some, epileptic activity in the system. Maybe a downtime and coming up, a downtime and coming up, which is very bad. I mean, I don't wish that, but what you can also experience is that the website can be very slow, okay? But I mean, when the load balancing is done and the auto scaling is complete and it has added another instance and it's properly configured, the website is going to pick up again. So in that scenario, the user does not feel any kind of bad experience of, I'm trying to go to the website, I can't visit it anymore, it's not working. No, the user just gets, again, the degraded performance we talked about in the beginning. So that's like the main thing in all this experience. We're trying to make sure the customer does not leave our website because we are totally unavailable when there was a downtime. So the tools that does this is, okay, I talked about use case. So I said apply a scalable load balancer like AWS application or classic load balancer will give consistent user experience. We give the user consistent experience, okay? And then the tools for this is AWS application load balancer, classic or network load balancer. Any of the load balancers can do the work, but though they all have their specific purposes. The next one to talk about is application caching. Now, faster login and quick access to data in cache gives the user the feeling of speed in your application and response. Instead of application round trip to your main database, you could cache certain information in your cache. Now, cache technologies store data in memory, making I/O faster, thereby making application faster. What do I mean by that? Another example I use very well is Facebook. Now, Facebook is backed by MySQL as their database. That's what Facebook uses for database. Very interesting that Facebook took MySQL to another level. But hey, one of the activities that people do a lot is posting status on Facebook, okay? You post something in Facebook. Now, because that activity is highly intensive in terms of writes, or another activity too, although people hardly log in these days because you can save your login in your browser. But before now, login was a very high activity, which was more of a read operation, because when you're logging in, you're trying to validate what is there to be sure that it is there before you give someone an access. Now, when you perform a login operation, you validate that data and then you are able to give the user access to the system. That kind of activity on your database alone is a lot. Because apart from just logging in, there are some people who are sending an email, sending a message. There are some people who are chatting. There are some people who are signing up. There are some people who are doing a lot of other activities. Now, this will bring a huge strain on your database to continue to do read and write operations at the same time. Now, databases are usually very good at write operations, but when the read is so high, it can cause performance issues. So because of that, what you can do to improve the speed of your system is you can take some of the data in your database and write it to another storage, which we call a caching storage. Okay, and an example is what we call elastic cache in AWS. Now, these storages are designed for high read. What I mean very easy, and you can quickly read data from this kind of systems. Now, because of that, what you can do is that you can take a lot of this data in your main database and take it in a system that you need to write, that you need to read a lot of data from, okay, which is like your caching I already talked about. And then for your application, you configure your application in a way that instead of taking people to log in straight to your database, they will log in via the cache. And then when they log in via the cache, their login becomes faster. Why does it become faster? I mentioned it here already. The input and output operation of a cache system is faster. And what makes it faster? Instead of storing data in the hard disk, which is where databases usually store data by default, it's going to store it in the memory of the computer. And the memory of the computer is usually very fast in terms of reading and writing operation. That is why we use it for many operations in the system. For example, if you go through the journey of how your computer works, okay, in terms of when you press a key on the keyboard, it goes through the hardware, gets into the software, okay, from the hardware to the software, back to the hardware again. One very important component along that journey is your RAM, or what you call your memory. Very important in the journey. It almost takes note of every single activity in your system, and it takes part in the processing of that data. There are even cases where operations don't even get to your CPU or your processor. Your RAM can decide to some level. And RAMs have evolved over time, creating what we call layer 1, layer 2, layer 3 cache. The whole idea is to improve how fast it's able to quickly do things. So you can take advantage of that value of the RAM and install a cache service so that when users are performing login, it can quickly get to the cache service, pick the information, validate, and give the user access. In that vein, users get better experience, faster experience when they use your application. I'm just giving a very basic example of login. There are many, many other applications people use caching for, okay? Okay, they use it for a lot of other things. For example, I think for emailing too, it's also used because when you send an email, what happens is that there are a lot of validations that go along the way. Now, they usually don't want to bother you about those validations, okay? So there is a service that helps to handle it in the background, but they'll tell you message sent. It doesn't mean the message is sent, because I'm sure you've seen the situation where you send an email, after 5 minutes, you get a response that this mail did not go, okay? So they are using a caching service to quickly store that information temporarily and validate every other thing. So is this email address, is it valid? The domain, is it valid? They do all those things in the background. When they have done it, they now go back to the cache, okay, and bring it back. So sometimes the cache serves as short-term memory for some operations so that you can carry out some things, thereby making the system faster and more efficient. So I said the use case here is use a cache service like Redis or Memcache to store login information so users log in via the cache and not the main database. And with that, you give your users a better experience of your application, because if everything needs to happen in the database, log in, sign in, sign up, e-message, trust me, your database is going to be very slow and not going to give users a very good experience in terms of using your application. So here, I think I made a mistake. I mentioned the load balancers again. So the service here is actually, so there are two services here that in AWS that does this work. You have DynamoDB DAX, okay? And then you have Elastic Cache. So in Elastic Cache, when you get to Elastic Cache, you're going to find Redis and Memcache there, okay? Then if you're using DynamoDB, the good tool to use is what we call DynamoDB DAX. It serves as what we call in-memory data store that you can use for application caching. I'm sure we are used to seeing this page a lot of times. It is annoying when a user sees a page like this. Most times they don't even know what's going on. Okay, so they actually get confused and can also expose your application to vulnerabilities. If you are a security person here, you will understand what I'm talking about here. I mean, one of the things you see here that is not good in terms of security is that, one, you are showing that you are using Apache server. Two, you are showing that your Apache is running on port 80, which gives a hacker a lot of information to work with. I say, oh, what I'm going to do, I'm going to run to CVE website and check the vulnerabilities in Apache server and start trying to, hack into this website. Oh, they are even using port 80, which means I can do DDoS attack on this IP address or this domain name and start hitting them hard and see their system go down. So another thing you also notice is that the user actually gets confused. They don't know what to do from here. They're like, what's going on? And they refresh the page. For some users, they refresh the page. Nobody check their internet connection. You push the user away and make the user more confused. So one good thing about user experience is that you need to give your user a beautiful, what we call status page. Now, a lot of web servers have this functionality, from Apache to Nginx, they all have it, where you can configure a special status page. What do I mean by that? If you go to GitHub, okay, and you type github.com/this is my country, that page does not exist on GitHub. But you're not going to see something like this. You're going to see, I think there's this beautiful girl or so, like a doll that stands and tells you, sorry, you are in the wrong place. Do you understand? And then you see a link there that shows you go to the home page. That's what we mean by an appealing status page. There's also this beautiful page Google used to have of a broken machine, a robot that is broken. The hands are broken, the legs are broken, and they will tell you, did you miss your way? Click here to go back. That gives the user a better experience, because the truth is there are pages that users can visit that don't exist in your website. There's nothing you can do about it. But instead of them seeing something like this, that is a direct response from your web server, you can handle that what we call problem, or what we call exception, because we're going to talk about exception handling next. You can handle that to make sure that the user doesn't see something like this, which is a security risk and also confuses the user, because the user doesn't even know what's going on. I mean, except you're a tech person, you know what 404 means. And this applies to every other what we call errors, 500, 404, 501, 502, 503. You can handle each of these errors in your system so that the user does not see this kind of error that confuses them, and you don't expose your system to a hacker that gets a lot of information. I mean, this information is even very minute. I see some web servers can show you the version, the build, which is a very high security risk for your system. It means that people can get this information and start attacking your system. And also, come on, your users love you so much. You don't want to throw them off balance by showing them something like this. So what we're trying to say here is, try and configure your web servers a lot, try and configure your gateways a lot, so that you can give the user a better interface, a beautiful graphic, and then with a link that says, okay, click here to go to your homepage, which you are guaranteed can work. Some people will say, click here and go to Google. They don't even know their website has a total downtime, so they will just send it to Google and go to Google and be searching what you are searching. You understand? So the whole idea of this concept is, make sure your users don't see something that confuses them, and make sure that it's not something that is exposing sensitive information that people can use to attack your system. An appealing status page. Okay, so this keeps a user calmer and user can still navigate. So this is a better example of what you should be able to do. So you can see the first one says, so sorry, Bugs is having a hard time finding the page you requested for. You understand? You can see showing you links, shop strollers, shop all feeding, shop all carts, I mean, you have options. You understand? You can still navigate. And the second one here says, sorry, we couldn't find it. Oops, very appealing. You have requested a page or file that doesn't exist. We notify the web administrator, check it out. And then it's giving you can either go to the home page, or you can go to the blog page, you can go to our about page, contact page, or go to our sitemap to even explore the website. So here, the user is not confused. The user knows, oh, there was a problem. Maybe this part of the site is not working. But there are options to go to other pages in the website. So the moral here is, handle all HTTP error codes and routes to a static page in S3. S3 is coming into play again. So this is something that you can still configure in your application, that you put a single page, maybe an error page in S3, a 404 page, so that if your website has a problem, you can quickly route the request over to S3 to show the user that kind of error page, so the user is not confused on what is going on. Properly handle all status pages. So another one here is, the use case here is using AWS Lambda at Edge or CloudFront. You can route based on status codes or configure your web server to direct to a static S3 website. The two services here, or three, is using CloudFront. CloudFront has this configuration. Actually, it's a very straightforward configuration in CloudFront, where you can design the different pages and where you want them to route to. You have Lambda at Edge, which is also a very beautiful service that combines Lambda and CloudFront to help you deliver a lot of unique features that are not usually possible by default in CloudFront. And then you have S3, which is practically where you might keep the website or the page you want the user to hit. The next thing here is MTTR. What's MTTR? MTTR is an acronym in DevOps, means mean time to recover. Now, your organization should have a stipulated SLA, service level agreement, for all services uptime and mean time to recover. Using tools like Uptime Robot can be helpful in understanding service health and measuring MTTR to be communicated with customers in the eventuality of a downtime. So this is more of a process than a technology thing. It's a way of making sure that you are within your organization, you have a process that says, okay, the system goes down in 10 minutes, we're unable to fix it, we do X. In 30 minutes, we're unable to fix it, we do Y. In 1 hour, if you can't fix it, we do Z. In 24 hours, if you can't fix it, we do this. So with that, you are still communicating with your customers. A company that does this a lot is Bitbucket. Now, if you use Bitbucket is known for downtimes, unfortunately. When it comes to all the Git companies, Bitbucket is, I don't know what's wrong with them. They kind of have frequent downtimes. But there's something interesting about their downtime that you can learn from. They continue to communicate with you, the customer. They put a message there and say, oh, we know the system is down. Our engineers are working on it. They will even tell you might have degraded performance. You might not be able to push code. You can pull code. They'll explain to you what is actually going on. That alone is a beautiful customer user experience that any user can get, instead of the system totally being blanked out and you are sending support message, nobody's saying anything. You are sending an email, nobody's saying anything. They just say, don't worry, we are working on it, Bitbucket Atlassian has a process of explaining what is going on and they update you from time to time, okay? And then using some kind of tools, like I said, Uptime Robot helps to monitor your system for availability. Okay, if there's an issue and sends you notification. The AWS service for this was not launched as at the time the slides were prepared, but the service for this is what we call CloudWatch Synthetic Canary. Okay, CloudWatch Synthetic Canary. That's why you should buy my book. I talked about it extensively there. Okay, so you can use Synthetic Canary to monitor your website, to know what's going on in your website, and a whole lot of things. Actually, you can do a lot with it. And then we're already rounding up. The last thing here is hiding exceptions and errors. Now, showing users the error in your application is not only confusing to the user, it also keeps the user stuck after seeing your error and not knowing what to do next. Always give users a beautiful error response and not the bug in your code and a proper way to route them somewhere else. It's very similar to the application status page I was talking about. Now, you notice that there are some websites, PHP written websites or WordPress websites, that when there's an error, you see it at the top. PHP error on so line page, PHP error on this error. Those things are not very good. It gets so bad that for some .NET applications, it will show you the line number, it will show you what the error is and everything. If you are a developer, you're working with the development team, encourage them to use what we call exceptions, try and catch. Because when you do try and catch in your code, whenever there is an error, the exception can catch it. And you can write a beautiful message and say, we are sorry, this system is having a problem, give us some time to fix it. I mean, just like I talked about before, that gives the customer or the user a lot of, okay, fine, the system is bad. Okay, what do I do from here? Then you can put a link and say, okay, go back to the homepage or click here to send a message to support or click here to contact us. That experience alone makes the user happy. But if I come to your website and I click and I'm seeing bugs, I'm seeing errors, what do I do with the errors? I'm just going to be looking confused. And I'm like, what are these jargons? I'm going to say, they want to hack my system, So you don't want to put the user in that kind of dilemma or that kind of confusion. You want the user to have a beautiful experience. And when they use the website, when there's an error, they see the error, they click on contact, they even type in your contact message and tell you what the problem is. So you can even fix issues faster and more efficiently. Now, the use case here is always use exceptions in your application. So the cut exceptions can write out cleaner responses because almost every programming language now have exceptions, from Java to C# to Python to Ruby to Node.js. They all have exceptions. So when you catch an exception, which is more or less an error, an unexpected action, you can write a message and say, hello user, I'm sorry for this. We'll get back to you. And then it becomes a better experience. All right. Thank you, everyone. Do we have any questions, any comments, any feedback? I'm open to receiving them now. Thank you.
Yeah, Ewere, thank you very much. I think that's a very, like you said, it's not the usual AWS kind of talk. I've been to a lot of them. Yeah, you've said just a number of interesting things, but I've learned a lot, and it's interesting to talk about. I mean, you've spoken about things which are very practical, which matters, but most of the time are not talked of, but you might learn the hard way when you now have a downtime and you are looking for options and what can I do to be more available. You learn those things the hard way, you know, but it's very good the way you've brought them up now. I mean, when I saw your list, your pointers before the talk, I was very interested to see how the talk will go, and I think it's very insightful. I mean, like I said, I've taken a lot away. I mean, the one which I never did think about is actually using Redis as a store, a kind of persistent store for, let's say, managing logins for high traffic sites and stuff. And I think that's a very good takeaway for me, which I think I'll prototype with some of the applications and infrastructure we manage. So I love what you did. So that's basically what I have to add.
Thanks a lot, Edwin. Thank you very much. So do we have any other questions, any contributions, comments?
Okay, so I want to ask about the anyway, thank you for the presentation. Very, very clear and practical as well, like Edwin mentioned. I wanted to ask about the DNS latency. I saw that you listed IPs. So I just wanted to know how that works. I mean, on a high level, how that works. I'm assuming it's probably maybe a routing policy on Route 53, but if you could touch on how that reduces latency. Thank you.
Ewere, you are muted.
Yeah, sorry. I said thank you for that question. It can be confusing sometimes. Okay, so I'm going to paint a good picture for you that you can grab. So let's assume you work for a company. Let me think of a company that you relate with very well. Let's take Amazon as a company. Okay. Now, Amazon has what we call Amazon.in. That's Amazon India. Okay. And they have Amazon.co.jp, which is Amazon Japan. Okay. Now, trust me, if you go to Amazon.com in Accra and you go to Amazon.co.jp in Accra, the speed is not going to be the same. Why? This is why. Because Amazon has Amazon.co.jp in Japan, there is a very high chance that the servers, the application services that are serving the people in Japan are located within Japan. Okay? Now, because you went to the Amazon global website, Amazon.com, there is a high chance that they are using CDN for it. Okay, so and the closest CDN to us, I don't know if they've turned on the one in Kenya, okay, the one in Nairobi, okay. Let's assume that one in Nairobi, that's the closest to you. Now, what they are going to do in the DNS layer is that, like you said rightly, yes, there's a routing policy called latency policy. Now, they are going to put two records there. They have record A, which is for Kenya region, which is closer to you in Ghana, in Accra. They have another record for the Japan and other parts of the world. So when you, the user, come and send your traffic over here, the DNS latency routing will check. The first record is to Japan, but the person's request is coming from Accra. This Japan is too far. It will cost 600 milliseconds to get to Japan. Do you understand? Then it will check. The second record is, let's say, New Zealand. These servers are in New Zealand. It will cost over 1 second to get to New Zealand. That's a lot of time. It checks the last one. Oh, Kenya. This is 200 milliseconds. Okay, I'm going to serve you traffic from Kenya. Do you understand? So the website becomes faster because it took all the records and checks the fastest in terms of response time. So it quickly does what we call a pre-ping. Let me use that word. It pre-pings the website, checks the time at which it gets a response, and decides the best place to route your request to based on your location on the planet. So the extra work you have to do is that you need to have all these records in your DNS layer and configure the latency policy. When you do that, it will be able to check which of the servers is closest to you based on the location you are coming from and where the server is located, and give you the application based on that location. Do you understand?
Yeah.
So it's like configuring CDN manually. Take it as manual CDN, because CDN is automatic. You know, in CDN, when you type the website, it gets to the CDN network. The CDN network will do a total ping to all their global POPs. AWS has over 202 POPs globally. So it does a global ping and say, based on where this person is coming from, which server do you think is the best? And then when it comes back with all the responses, it sees the shortest time and sends you to that POP server. Do you understand? But in DNS failover, you are configuring the servers yourself. Do you understand? So there's a thin line between DNS failover and latency. And CDN, content delivery network, there's a very thin line. CDN is fully automatic, but latency is semi-automatic. But there's another thing here you need to understand. For CDNs, they work very well in terms of streaming data and static content. So when I mean static content, HTML, CSS, JavaScript, or video streaming and all that, do you understand? When it comes to dynamic content, you don't really see CDN being largely used because the content is dynamic. Don't forget that CDN stores data. Do you understand? So if something changes in your backend, your CDN needs to update. So using CDN for dynamic applications is not a very, very easy thing to do. It can be very tricky. Do you understand? So the next thing here is, for DNS latency, you will not have that problem. Do you understand? For DNS, you can't have that problem. Everything is just going to work fine. You understand? But you need to see the pros and the cons. Another thing again about DNS is that you spend more money, because it means that you have to set up your application in different availability zones and regions. Do you understand? So you will duplicate your applications that will be running live. But CDN, you don't need to duplicate your application. The CDN service will duplicate it for you.
Okay.
Do you understand? So they have their pros and their cons. So very, very large companies that have a lot of customers, they will definitely use DNS latency, because you don't want, because you hosted in Ireland and those in California have poor experience, you will set it up again in California region and use DNS latency to ensure that those in California have better experience, because the DNS is routing to the California availability zone and region, while those in the island get another good experience too, because they are routing traffic to the island availability zone and region. I hope I've cleared it now.
Yes, very clear. Very clear. Thank you.
Right. So any other questions? All right, while we think about questions, I was talking about uptime, and I talked about my book, and Iman also talked about it when he was starting. And yeah, so basically the book, it's on Amazon CloudWatch. It was launched last week, and I will tell you for sure, not because I'm the author, but one of the things you will get in the book is that I took time to take monitoring from the ground up, okay? I've noticed a lot about how people see monitoring as an afterthought. When you have finished setting up, you have deployed, you're not thinking, what do we even use to monitor? Let's do Datadog. Let's do, by then it's already leaks, because there are parts of your system that require monitoring during development that you need to take note of. Those are some of the things I talked about in the book. Then I took monitoring from the ground up. So if you don't know monitoring before, you have heard about monitoring, you have read about it, you want to understand the process of monitoring, you want to understand the concepts, you want to understand the foundational concept of monitoring. Because when you understand the foundational concepts, it will help in terms of choosing the right tools to monitor. You don't have to use CloudWatch, okay? But it will help you to choose the right tools. It will help you to understand the monitoring strategy. It will help you to introduce to you observability. Okay, the book talks about observability too. What is observability? What are the components of observability? This whole observability thing, what is the idea? How is it different from monitoring? Because a lot of people don't understand that there is a difference between observability and monitoring. They are very different concepts. They are not the same. Okay, so don't worry yourself. If you get the book, you will understand how they are different and why they are different and why observability is getting a lot of attention now than monitoring is. Although monitoring rides on observability, but observability on its own is on its own, is an item on its own, but it's going to still rely on some concept of monitoring to work effectively and for you to get results on. And in the book, I touched monitoring across all services, okay? Compute, databases, and networking, data engineering, or what we call big data. And yeah, so you can understand monitoring across board. And I went extensively to talk about how to configure it for EC2 instances, okay? There are also situations where people don't know what to monitor and how to monitor it effectively. I also talked about it, okay? If you're in an EC2 instance, there are certain things you need to have and monitor them effectively. If you are doing containers too, I talked about container monitoring extensively, ECS, EKS, how to monitor it, how to configure monitoring step by step. So if you follow the steps, you can configure monitoring properly. And I also talked about how you can use infrastructure as code as a proper way of setting up a scalable monitoring strategy for your organization. So those are some of the things you will see in the book, and I urge everyone to get it. I'm going to share the link on the chat right now where we can get it. It's on Amazon and it's also on the publisher's website, which is Packets. Packets is the publisher. You can get it there. You can also get it from Amazon website. So that's the link to the book. Thank you very much. Over to Edwin and Emmanuel.
All right, thank you very much. At this point, yeah, just like we usually do, we give away 225 AWS credits. So I will take over the screen, if you don't mind, Ewere. So probably you can stop sharing your screen.
And being that I'm here, I'm going to give you $150 credit that you will give out to. So there's a bonus.
Wonderful.
So I'm going to send the credits to you, and you are going to distribute it out to the lucky winner.
All right. So I think what we'll do today is we will do. Anyway, let me take over the screen, and then
all right.
agree on the format for today's raffle. All right. So we have our raffle application here. Yeah, the fewer the merrier, they say. So the participants today are quite few. So we have Mavi, we have Nathaniel. Some people joined, they dropped off. I mean, once you are not here, you can't be part of the raffle. Okay, so usually we will spin twice, and each winner will get 25 AWS credits. But Ewere is saying he has it's $150 credits, right?
Yes, $150 credits.
Okay, all right. So I'll do the first two spins, and then I think what will happen is the person who will be left will automatically qualify because it's 3 people. The first 2 will win the 25s, and then the last person will win the 50. Otherwise, we will be forced. Somebody will have to. So that's what
it means that if you want to win, then don't be drawn.
Don't win. If you want to win, don't win.
Yes. So it's more of an invest right now. Yeah. So
yes.
Right now, when you become a winner right now, it's not too interesting. Yeah, but let's see how it goes. All right, so let me go ahead. Take our first spin. All right. So Mavi is getting 25 dollar credits. Let's see the
Thank
next.
you.
You're welcome. Let's see the next winner or loser, if I miss. Everybody's winning. Some are small, some are bigger. Yeah. Okay, in fact, so I'm
Great.
sure if Ewere was to choose, he would have given Daniel, because Daniel is the only one who asked a question. Exactly. So if yeah, so Daniel,
This is luck and opportunity meeting each other.
exactly, yeah. So Daniel gets the 50, Marvin and Nat will receive the $25 credit. So
Maybe can you confirm you received it? I sent it to you.
via what? How did you send it?
On this chat.
Oh, wow. On this chat, did you send it?
Yes, obviously I did.
I just want to know.
They would have taken it and they will not tell you.
I'm telling you. Oh boy. Yes, I have received it. Let me just quickly save that. So thank you.
All right.
And well, thank you very much. It was a very nice talk. I think we didn't publicize the event well enough, and we had some challenges planning the event, but I think we will definitely schedule another event and plan it well so that we can get better attendance. But all in all, I mean, there will be a playback on YouTube so people can catch up and all. And thank you very much, Ewere. Thank you everyone for attending. The winners will definitely receive their credits, and we'll look forward to another event next month, right? Yes, April is just ending, so next month we'll look forward to another event. Thank you all.
Thanks everybody.
Right.
Have a wonderful day.
Thank you everyone for attending. Nice day.